Hi everyone, my name is Sheldon and I will be the 31st reporter on Elective 4 under Engineer Showna L Salas, and my topic would be the water planning and resources under Reservoir. So we're going to talk about the uses, how we construct the reservoir, what is the importance, and etc. So water reservoir is a man-made lake or large fresh water body of water. Many people think of reservoir as a lake and might even use the words interchangeably. However, the key difference is that reservoirs are artificial and made by humans, while lakes are naturally occurring bodies of water. Reservoirs are great because they provide a supply of water for when naturally occurring bodies of water like the lakes or the rivers and run dry. What is the use of the reservoir? So it actually gives us a lot of benefits. One of those is the drinking and the municipal water supply. Second, we have the industrial and cooling water supplies, and of course, the water generation and agricultural irrigation, the water regulation and flood control, commercial and recreational fisheries, body contact recreation, boating, and other aesthetic recreational uses, navigation, canalization, and the waste disposal in some situations. It can also be formed from a natural lake whose outlet has been dammed to control the water level. So the dam controls the amount of water that flows out of the reservoir. Rivers reservoirs are entirely man-made and do not rely on damming a river or a lake. This reservoir is sometimes called the cistern. People have been creating reservoirs for thousands of years now. The oldest known dam in the world is the Jawa Dam in what is now known as Jordan. It was built in about 3000 BCE to store water to use for irrigation and or watering crops. People build reservoirs because the amount of water in a river varies change over time. During very rainy times or when the mountain snow is melting, the water in a river rises and sometimes overflows its banks. By limiting the amount of water allowed to continue downriver, reservoirs help control flooding. And as we all know, reservoirs helps in generating power. And here in the Philippines, we have actually nine dams or reservoirs. Um, that's very helpful when it comes to electricity generation. So we have here an explanation how um, the electricity converts from water going to and we're gonna use it in our daily uses. So I have here a video that explains everything.
100 170,000 cubic meters of water flow past here every minute at almost 60 kilometers per hour. That's enough water to fill about 100,000 Olympic swimming pools every day. Standing here, you can actually feel the power of the water. Harnessing that power is what hydroelectric stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling water into the flow of electrons, or what is commonly called electricity, the electricity that powers the province. Most hydroelectric stations use either water diverted around the natural drop of a river, such as a waterfall or rapids, or a dam is built across a river to raise the water level and provide the drop needed to create a driving force. Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called the stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines. The falling water, having served its purpose, exits the generating station to the tail race, where it rejoins the main stream of the river to continue the cycle of creating clean, renewable energy for Ontario.
Okay, and we have actually three types of reservoirs. So first, we have the valley dam reservoirs are created in valleys between mountains. So usually there is an existing lake or body of water. The mountain sides are used as the walls of the reservoir to hold the water. A dam or the artificial wall in the reservoir is built at the narrowest point to hold in the water. And second, we have the bankside reservoirs, reservoirs that are made by diverting water from local rivers or streams to an existing reservoir. Although this can be applied to many different geographical areas, unlike the valley dam reservoirs though, which requires a valley, diverting water from a river can create problems. So the River Thames in London is one of the examples of the bankside reservoirs. The last type of the reservoirs, the service reservoir, which is very common to us, usually in the countryside, are entirely man-made. They are usually stored in a concrete basins above or below ground. You might be familiar with the large water towers in the countryside. This water tower is a service reservoir. In some areas, people dig certains or service reservoirs that are underground. So certains must be in a place where higher elevation to allow the water to flow where it needs to go, whereas water towers are already at a higher location than the surrounding lands. And I know we sometimes, or personally myself, I use the word interchangeably, said the dam and the reservoir. So unfortunately, descriptive nomenclature of artificial created water bodies is frequently confusing. The term dam is often applied to both a physical structure retaining the water and the water so retained. Dam will be used solely to describe a physical structure, and the term reservoir will be used to denote the artificial created water bodies. So we have two things to remember to differentiate the dam and the reservoir. So first, a water body contained by embankments or a dam and subsequently managed in response to specific community needs. And the second thing is that any natural waters modified or managed to provide water for developing human activities and demands. So how does the dams constructed in what are the variations or things to consider? So much of the variation in construction of reservoirs is the result of the original purposes for which they were constructed, although their principal uses can change over time. Other elements of variation in form are introduced as a result of regional geology and the availability of construction materials. For example, where clay deposits are plentiful, dam or embankment construction may be based on the earthen structure with impervious clay cores, while in other areas dams may be constructed solely of mass constructed. So there's a video here. He's actually a civil engineer from the US, and he has a little project to entice students to be more or to inspire to be a future engineer. He created a little he showed how to construct dams and reservoirs.
This will probably not come as a surprise to most of you, but making YouTube videos is just a hobby for me. I make my living as a civil engineer. And my wife is a teacher at an elementary school, which means I get invited to Career Day every year. And I really enjoy this because I like what I do, and it's a fun challenge to try and make it interesting to young people. I practice mainly in the field of dams and large hydraulic structures. So this year I wanted to build something to illustrate some fundamental concepts of water management. My idea is to construct a model of a dam and reservoir, kind of in the style of a children's science museum exhibit. I cut out this piece of 3/4 inch plywood and then rounded over all the edges. Then I screwed on all the cedar 2x4s. I'm using Titebond 3 here, which is a waterproof glue, although it's not really designed for submerged applications. But this is only intended to be the last line of defense against leaks. It's also a little chilly out in the shop this week. The bottle says keep it above 45, and it's just about 50 now, so I'm hoping it stays that way for at least a few more hours while the glue dries. I cut some windows for the valves, drilled holes for the pipes, and started on some of the plumbing. Then I coated all of the surfaces which would be getting wet with marine grade epoxy. The goal here is to prevent leaks and keep the wood from becoming saturated, which might cause it to swell or mold or just be too weak. I've never built a wooden boat before, but I think this is how they do it. The epoxy built up a nice thick film and filled in any cracks and holes, so I'm feeling confident that this thing will be able to hold water. I'm checking the temperature on the epoxy too, just to make sure that we're within the recommended range since it's still a bit chilly outside. While the epoxy was drying, I built the legs which will hold up the display. These are removable so that the display will still fit in my car. After the epoxy was cured, everything got a coat of exterior latex primer. I figure if this paint can stand being in the weather and the sun for several years, it can probably stand to sit underwater once or twice a year for a few hours. I got these little sample sizes of colored latex paint. I had no idea you could do this, but these are really cheap, like a few bucks. And the big box stores will mix it to whatever color you want, and it's really high quality paint. For the PVC pipes, I use spray paint designed for plastic. So I did a lot of masking and a lot of painting to make it look nice. And then I use a projector to get the lettering on the display and then just Sharpies to fill it in. For a few finishing touches, I painted this computer fan green to use as a hydropower turbine, and I put this fake grass to use as a lawn. The last step was just to add a nice bead of silicone caulk all the way around the edges and install the acrylic sheets. I pre-drilled all the holes, and I used Kreg pocket screws to hold the acrylic down because they have a nice flat washer head that distributes pressure evenly and will hopefully keep from cracking the acrylic. And I set my drill clutch to the lowest setting to make sure I didn't over-tighten anything. This is my favorite part. So here's how the display works. Water is pumped from a tray behind the display to above the lake to simulate rain filling the reservoir. A flood can be simulated by pouring in a pitcher of water. I built a small crest gate to act as a flood control structure. It doesn't seal very well, but it gets the point across. There are houses along the bank of the river downstream to show how flooding can affect structures near rivers, and it's easy to see that a house built at a higher elevation has a lower chance of flooding. Hydropower is simulated with the computer fan, and water supply is represented by this garden hose and bathroom sink. And low flow releases can be made from the dam to keep water in the river downstream. And there are some fishes here to show why environmental flows are important. And everything drains back to the tray behind the display. The overall goal here is just to illustrate some purposes of a dam and reservoir and give simplified explanations of how some of the different systems work. And I think it was a big success at Career Day. I had a lot of interest and engagement, a lot of good questions, and hopefully sparked some interest in engineering, and maybe even inspired a budding dam engineer. Thanks for watching, and let me know what you think.
Okay, so I mentioned a while ago there's actually a nine dam or reservoirs in the Philippines that we highly prioritize. So we have here a list of dams It shows the graph shows how much volume has they been provided for us as of February 2021 on the household they actually and on the area. So we have the Ambulok Dam, which is the it provided a highest volume of water. We have the Banga Dam, Kaliraya Dam, San Roque Dam, Angat Dam, Pantabangan Dam, Magat Dam, Ipo Dam, and La Mesa Dam. And that's it. It's all about the reservoir. So once again, my name is Sheldon. Have a great day and thank you so much.